Hello everyone. In this video, I'd like to take a look at a piecewise function just to talk about some of the properties of these functions. So I have the definition here again. It says a piecewise-defined function is a function that is defined by different equations on different parts of its domain. So normally we're going to deal with a function that is spread across all real numbers, so everything from negative infinity all the way to positive infinity. However, on different intervals within the real numbers, our function is defined by different equations. So I go down to the example I have a function f of x, and we're using the big bracket here. It looks sort of like a system of equations, but these are describing the different pieces of our piecewise function. And then the second piece, or the second half of this is telling us exactly where each of these things is happening. And they normally go in numerical order. So the first one, my function is defined as -1, so that's a horizontal line, for everything that is x such that x is less than 0. So everything from 0 to negative infinity is defined by this first equation. Once I get to 0, it makes a switch. So at 0, now my second restriction here is for everything such that x is in between 0 and 3. So for all of those values of x on that interval, my equation is defined by 2. And lastly, once we get to 3, we make our last switch, and now my function is defined by the last piece of my equation, or my last equation. So 2x minus 4 for every value of x that is bigger than 3. Okay, so what I like to do is I want to evaluate 3 different values, and I want to graph this just to give you a visual on what this would look like. So the first thing to evaluate, we just need to make sure that we are following the intervals that are laid out for us. So the first one, we have f of -4. Now I don't need to plug this into all 3 things. We only need to plug it in to the correct interval, depending on what value of x we have. So my value of x is -4. So where does that fall? -4 is smaller than 0. So that means we're going to use the first equation. Okay, this is just a constant. So no matter what we have, this is going to be equal to -1. All right, now second, we have f of 3. Again, we're going to go to our intervals to see where this falls. And I do see that 3 is in 2 spots here. However, this one does not have the or equal to part. So that means for f of 3, it falls into this middle interval where x is equal to 3. And same thing, this is a constant. So for everything in between 0 and 3, we end up with a result of 2. And then the last one, f of 6. Now we'll go back to our intervals. 6 is bigger than 3, so it fits this interval here. So that means we want to use this last equation. And in this case, we do have a little bit of algebra to do. So 2 times 6 minus 4. So if we simplify that, 2 times 6 is 12, minus 4. So f of 6 is equal to 8. Okay. Now these results, these are basically y values as well, so they can help us out when we're trying to graph the function. And I'm just going to do a sketch. Nothing too fancy, but just to give you an idea on how this would look. So make a couple axes here. Okay. Now what I like to do is just take note of where our switches occur. So we go all the way up to 0. That's where our first switch is going to happen. And then we have another switch that's going to happen at positive 3. So 1, 2, 3. So we'll have another switch at this x value. And I'm going to put a couple tally marks just so we can plot some things. Okay. So if we go piece by piece, our first one, for everything that is less than or equal to 0, we have the value of -1. So that's a horizontal line, and it is just less than. There is no or equal to part. So if I kind of think going backwards here, actually, so starting at 0 all the way to -infinity. But it doesn't have the or equal to, so we're going to include a hole for that because we want to get up right next to 0, but we don't actually want to touch it. So then starting there, and that first piece of the graph goes all the way to -infinity. And now the second piece, so the one in the middle, everything in between 0 and 3, and also including 0 and 3, it's going to have the value of 2. So again, that's another horizontal line. So at 2, I'm going to use a closed point because I do want to include that. And then over here at 3, also at a y value of 2, another closed point, include that one. And then we'll connect that with a horizontal line, and there's our middle piece. And then our last piece is our last bit of our last equation, 2x minus 4. So everything starting at 3 but not including 3, then everything all the way to positive infinity is represented by this. So this is going to be a line, and just to get an idea of where we're going to start, I'm going to see what I get when I plug in 3. So f of 3, 2 times 3 minus 4. This is going to be 6 minus 4, so we're starting at 2. So at 3, 2, this is where this piece of our graph is starting. And this piece doesn't include it. We do have a little overlap there, but that's just fine. And then I can use my slope from here. So up 1 over 2, and just to get a couple points to sketch. Up 2 over 1, using my slope. And then to put a point with that, a line. So starting here, and that's going to keep going all the way to positive infinity. So hopefully that makes sense. In this case, we have 3 different pieces of our piecewise-defined function. Each one represents a different interval, but altogether they make up the entire all real numbers.